Alright, ladies and gentlemen, in this video we're going to be covering complex numbers. Complex numbers are related to imaginary numbers, and we'll also be getting to that in this video as well. But just a reminder of what these numbers are all about, or why these numbers are going to exist, is if you recall a couple weeks ago we talked about taking the square root of numbers, and how it's only possible to take square roots of positive numbers. There's no way we can take the square root of negative numbers. For instance, square root of -4. I can't do that because essentially what I'm asking here is what number can I multiply by itself to equal -4? And, well, there is no such number because the only way I can multiply anything to a negative is if I multiply a positive with a negative, which of course then those are not the same because they're opposite numbers. So there's no possible way I can multiply any number by itself and end up with a negative. Because if I multiply a positive number by a positive number, I end up with a positive number. If I multiply a negative number times a negative number, I still end up with a positive number. So there's no way I can multiply something by itself and end up with something negative. It's always going to be positive. Alright, so that's the reason why these numbers are going to exist. Because what we're going to do today is basically take the square root of -4. We're going to be able to do that, but in a more theoretical sense, rather than a real-world sense. Of course, if you try to take the square root of a negative on your calculator, let's go ahead and let me show you that real quick. If you try to take the square root of a negative number on your calculator, let's do the square root of -4. Right? Okay, answer. I get error, right? Because I can't do it. There's no negative number I can take the square root of, and it would work. Every time I do it, I would get this error message. Alright, but there is sort of a way to do it, and it's called using an imaginary number. A number we're going to call I. So define and use imaginary and complex numbers. That's our goal today. Solve quadratic equations with complex roots. So these definitions, we'll be talking about all these things throughout this video. I might split this video up. I don't know. We will see. Alright. So, just a general consensus on what this is going to be. For quadratics particularly, notice if this quadratic does not hit the x-axis, right, then it has no solutions. Remember we said that? Technically no real solutions. That's kind of the key phrasing. Because there are solutions here, it's just imaginary solutions. Right? Remember, the solutions are the points where the parabola intersects the x-axis. Of course, the one you're seeing on your screen right now, that parabola does not cross or touch the x-axis, so it has no real solutions. But it does actually have imaginary solutions. Okay? Imaginary unit, I, is defined as the square root of -1. So that's going to be the main thing that we're going to be looking at today. The square root of -1 is called I. We're going to call this I. Alright? So, anytime I see the square root of -1, I'm going to just replace it with I. Alright? So, an imaginary number, this, of course you can see that here, square root of -1 equals I. Now, if I wanted to take the square root of -2 or -4, here are just some examples of things we'll do. We're going to separate the negative from that number. So, I'm going to separate the negative from 2, creating this -1 times 2, right? Because -1 times 2 would still be -2. But I'm separating it so that I can have the positive 2 and then put the negative over here. Because this is going to become I, the square root of -1. Alright? Yeah, as you can see here, the square root of -1 becomes I, and the square root of 2 remains the square root of 2. So it's basically a way that we can effectively remove the negative from the radical. And it sort of appears as I. One thing to really point out is right here. If I take the square root of -1, or my I, and I were to square it, right, well, then I could actually effectively, the squaring and the square root sort of cancel each other out, and I end up just with -1. So if I see I squared, which again is the same thing as here, those two things are exactly the same, because square root of 1, remember, is the same as I. If I take I squared is actually a functional number. It's negative 1. The square root of negative 1 is not functional, but of course, a regular negative 1 would be. So just keep that in mind. If I were to square I end up with negative 1. All right, well, this one's sort of already kind of outlined for you, but here's sort of the idea of what we're going to be doing today. So if I'm going to do the square root of negative 25, well, again, I can't do that because I can't take the square root of a negative. So what I'll do is I'll separate my negative from the 25. I'll write the negative as negative 1, and I'll write my 25 as my regular 25. So I'm separating the negative from the 25. Of course, the square root of negative 1, I identify that. We call this I. And the square root of 25, we already know that is 5, right? So I have I times 5, or it's better written as 5i. So you can see all the steps here. Of course, if I want to rewrite it so I can explain it as I worked, it has kind of the functionality of imaginary numbers. So if we were to try it with this one, all right, notice this is 5 times the square root of negative 121. We'll worry about the 5 in a minute, but let's go ahead and start simplifying the square root of negative 121. Now, because it's negative, the square root of a negative number, I can't functionally do that, so what we're going to have here is an imaginary number. Let's separate this negative from the 121. So I'll write the negative out as negative 1, the square root of negative 1, and the square root of 121. So I'm separating the negative from the 121. Of course, remember this, we identify the square root of negative 1 as I. So this is 5 times I. And then times the square root of 121. The square root of 121 is 11. So I have 5 times I times 11. I can multiply my numbers together, right? This is the same as just 5 times 11. I, which would be 55, right? 5 times 11 is 55. 55i, of course. So this I is here to kind of besides the fact that this is imaginary. If I were to type this in my calculator, it's simply not going to work. But if we separate the negative out, we can call it I, and so we basically have an I sitting around in our answer here to indicate the fact that it's imaginary. Alright, so here I have a negative on the outside. A lot of people might think, hey, you know what? A double negative, that cancels each other out, right? Well, not in this case because we have a negative outside the radical and a negative on the inside of the radical. I can't really combine them because the radical is in the way. Remember, if it's inside the radical, it's pretty much locked in a safe, and we can't really affect it with the radical there. Okay? So none of that's going to change unless I can somehow remove the radical, but that's not my goal here. Alright, just that's the reasoning why we can't combine these negatives right now. But, same as last time, remember that 5 that was sitting on the outside last time? Right? If I can go backwards, let's erase this. The 5 that was sitting out here, remember that's kind of what this negative is going to do that's sitting on the outside. So it's going to sit out there. Let's go ahead and separate my negative from my square root of 96. So there's my negative 1. And here's my 96. So again, in this step, I'm just separating the negative from the 96 so that I can take the square root of 96. Of course, remember we identify this as I, so I technically have negative I right now. And square root of 96 is not a perfect square, because remember the perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, of course. So 94, which would be somewhere in between those, or 96 rather, is not a perfect square. So let's simplify. We've simplified these in the past. I've got to figure out what perfect square will divide into 96. So let me try a few. I think, let me use my calculator. So I'm going to have to erase this, and I apologize. Well, maybe I can keep it and just erase it later. Alright. Well, spoiler alert, there it is. But if you didn't already know, let's go ahead. Quit. Alright. Let's see, 96, can I divide it? What's a perfect square? Let's start big. By 49? No, it wouldn't work. So what's another one? 96, can I divide it by 36? No, I can't. 96 divided by 45. I know 25 is not going to work. What about 16? Yeah, so go through, if you're not an expert at your multiplication facts, just take your number, divide it by some perfect squares until you find one that works. And of course, ideally, you want the biggest one that works. So 16 times 6 will work. So let's go back to the PowerPoint. All right, back to this process. We'll have the square root of 96. We can write this as the square root of 16 times 6. And of course, now we're just simplifying this. So let's break this apart. Square root of 16, square root of 6. Square root of 16 is 4, and square root of 6 does not simplify, so I leave it exactly the same. But don't forget my negative I is still here. So I have negative I for square root of 6, but typically we usually will write the number in front of I, so it'll really more look like negative 4I square root of 6. Okay? Again, that negative pretty much stayed around, stuck around the whole time. But yeah, just like you would write 2x as 2x, you would never write 2x as x2, right? That just looks weird. That's why we're going to write I4 as 4i. It's pretty much this is sort of how we're going to be used to seeing it, just like we're used to seeing 2 times x, the number kind of in front, as a coefficient rather. So that's the reason why I rearranged there. I guess it's not technically necessary, but it is sort of how you'll see your typical answer choices. Oh, yeah, go ahead and start. You can see, of course, they got that answer there as well. Yep, negative 4i square root of 6. Again, I is never going to be inside the radical, okay? So you're never going to have the square root of, like, I. That wouldn't make any sense, really. So remember, I is always in front of the radical, essentially. You never want to write I after the radical. Always put the I in front. All right, so square root of 12, let's go ahead, or negative 12 rather. Again, separate your negative from the 12. Remember, this we identify as the letter I. That's imaginary. And the square root of 12, we can simplify this. I know 12 I can break into 4 times 3. 4, again, is a perfect square. So we can make this square root of 4, square root of 3. Square root of 4 is 2. The square root of 3 does not change. So I have essentially, my I here, so let's rearrange that. Let's put it as 2i square root of 3. That would be my answer on that problem. Alright, so now let's start solving things. Now this is not imaginary just yet, but I wanted to make sure I mention something about these problems before I move any further. X squared equals 81. So some people might, this is one set problem, you might already be answering this in your head. What number do I square to equal 81? And, many of you are probably already shouting out the answer. But here's the process of how we're going to solve this just mathematically. If I want to get the x by itself, then I have to remove the square. So just like anything else, when I'm solving, what's the opposite of squaring something? The opposite of squaring something would be to square root something. Okay, i.e., I outline this here. So if I square root the left side, I'll remove my square because those things cancel out. If I square root the right side, of course, I have to do it to the left. So I'll have x equal, now the square root of 81, again, many of you are shouting out the answer. I know it's 9, but technically, it's positive and negative 9. So both x equals 9 and x equals negative 9 are technically answers here. And instead of writing them, twice like I just did, I'm going to write it like this. The plus and minus here are to indicate that I'm talking about both the positive and the negative version of 9. So it's just a way of writing the two numbers at the same time, essentially. So when you see the plus or minus, remember, that's just there to indicate both the positive 9 and negative 9 simultaneously. But why? Why is it both positive and negative? Well, because that's what x could be, right? A positive 9 squared is 81, but also a negative 9 squared is 81. So technically, x could be either of those numbers because technically, they both work. If I square 9, I get 81. If I square negative 9, I get 81. So let's not forget about the negatives, okay? All right, so let's solve this one again, real fast. Following the order of operations like we normally would, I'm going to be adding 5 first here. Remember the order of operations backwards when we're solving problems here. Remember the order of operations PEMDAS? Right. Well, when you're solving, you work in a backwards fashion. So we do anything I'm adding or subtracting, and of course I'm subtracting 5. Let's take care of that first, and then we'll work our way down the ladder here. So I'm subtracting 5. I want to move it, so I'll add 5. That's going to get me, the 5's gone. We'll just have 3x squared. Oops, not a 2, a 3. Okay. A 3x squared on the left equal to 43 plus 5 is 48. Alright, and now I'll work on anything I'm multiplying or dividing. So I'm currently multiplying 3 to my x, so I will divide that 3 because that's the opposite of multiplying. Now I have x squared equals, I believe, 16. Right? And now I functionally have the exponent to get rid of, right? That's what I would do here, the e. So I can get rid of my exponent. The opposite of squaring something is to square root it. So if I square root that side, I'll remove the exponent and just have x equal to, of course, square root this side as well. Again, if you're shouting out the exponent, don't forget it's positive and negative 4. Square root of 16 is both positive and negative 4. Okay? Again, simply because positive 4 squared is 16 and negative 4 squared is 16. Alright? So, this also comes into play when I have imaginary numbers. So we'll see that here. I have the x squared equals negative 144. Now technically, again, I know this is not possible because I know I can't square a number and get a negative outcome. That's not something I can do. So it will be imaginary. You'll see that in a minute here. But if you're already looking at this problem, you might have already noticed that. So, again, I want to get the x by itself, so I'm going to square root this side because that's the opposite of squaring something. So that's going to basically cancel that out, leaving me with x. But when I square root this side, of course, now you see I have, I'll just write it down here again before I work it out. I have the square root of negative 144, which again, I can't do the square root of a negative number. So, just like the problems we did previously, oh, by the way, remember this is going to be a plus and minus, okay? Because when I square root something like this, I technically have a positive and negative version of it. So I'll also go ahead and simplify my square root of 144. So I'll separate my negative from my 144. Of course, I have my plus and minus. We talked about that previous slide. Because we'll have a technique when I square root something. You can see that here. Erase all on the slide. When I square root something, I'm going to end up, I have to put this plus or minus here to indicate that we're going to have a positive and negative version of it. Technically will work. So that's why I'm putting it there. I'm putting it there preemptively, pretty much. But it's still going to be there. Alright, we know that this is I, right? Square root of negative 1 is I, so plus or minus I. The square root of 144 is 12. So let's go ahead and just rearrange these. It's technically x will equal positive negative 12i. Alright, it's curly looking I. Apologize, it looks terrible, but that's our answer here. Okay. Don't forget the plus and minus. It is important. Anytime you're square rooting something, there's technically going to be a positive and negative version of the answer. You can see, I guess, here when they check their work. 12i squared is 144i squared. But remember, we talked about that not too long ago, that I squared is equivalent to negative 1. I equals square root of negative 1, but I squared equals negative 1. So that's 144 times negative 1, which of course is negative 144. So that works, right? We plug it in and we get negative 144. If you use a negative 12i squared, well remember negative 12 times negative 12 is a positive 144. I squared is still I squared, so it's still 144 times negative 1, which of course gets me, the answer. So that's why, again, there's both a positive and negative version of these. Keep that in mind. Alright, so just one more for this video. I'll probably do the rest of it in a separate video because we'll probably separate this in a couple of days class time. But here, same process. Let's subtract my 90 because remember we're working our order of operations in reverse. So I'm looking for adding, subtracting right now. I'm adding 90, so I'm going to go ahead and remove it by subtracting 90. Leaving this 5x squared equal to 0 minus 90 is negative 90. Alright, now I've done the adding, subtracting, let's move over to the multiplying, dividing. I'm multiplying 5, so I'll cancel it out by dividing by 5. That'll leave me with x squared equal to negative, what's 90 divided by 5? 18. Alright? Alright, so now I gotta take the square root. To remove the squaring, to focus on my exponent now, I remove squaring something by square rooting something. So I'll square root both sides. I'll have x equal to, again, don't get the positive negative in this part. Whenever you do that square root, it's going to be positive negative. I'll write the negative 18 for now, but I will go ahead and simplify this in a minute. So square root of negative 18. We do need to simplify that. That is not a perfect square. Let's go ahead. Let's separate the negative from the 18, and then we'll focus on the 18. So remember, this becomes I, so I have plus negative I. And 18, I can split this into 9 times 2. So let me go ahead and carry that over here for a second. Positive negative I square root of 9 times the square root of 2. So this becomes 3, and square root of 2 remains the square root of 2. So I have essentially positive negative, okay, I3, which is again 3I, square root of 2. So it's definitely going to be kind of weird at first, but it's really absolutely no different than what we did last week, with the only exception of separating the negative and calling it I, basically. And when we solve these problems, when we square root them, we have to have the positive negative version. I think last week we had the square root problems, and we squared them to remove it, but now we're doing the opposite. Now we have the square, and we're square rooting them to get rid of it. Alright, I'll stop here. This video, I think I've rambled on long enough. I'll continue this in the next video. We will see you there. Bye-bye.